Hello everyone, this is Ali Reza. This is another episode of RPG API Core. And if you recall a few episodes before, we were creating our graph and we were stuck because, this graph utility is sitting inside common editor utility. And the node editor window that we want to get instance access to is sitting inside node graph editor. And we are referencing common editor inside this guy, if you look. And we can't reference it back node graph inside common editor because it would cause infinite loop and no sane IDE would let you to reference two projects to each other like that. So we were stuck. There was no way of us getting access to node editor and its instance. And the only way that you can get access to it is by using reflection. That was why I stopped the project there and went to create our reflection utils. But the reflections utils that we have right now is not done. It's not finished. And we will come to this class every now and then and add on top of it every now and then. One of the things that we need to add right now is this. If you look, the node editor window has this public static node editor window instance. This is called a singleton, okay? Because at any time in the project, we will have only one node editor window, and god damn it, please shut up. There. So, and what's the problem with you? Initialize, I don't care about initializations. And what's now? Yeah, go to hell. Okay, so this is a singleton. What's the meaning of singleton? Is that at any time in working time, we will have only one and only one node editor window. So we should be able to get access to it by using a static field that gets access to this guy. But I can make this a property. Why not? Okay, and I will say private set because I can do that. This is the only class that is setting the property here, so why not do that? So now that I have a property, don't forget before this it was a field and it's now a property. I can use with reflection on both field and property, but when I'm working on singletons, I prefer to have properties. Okay, so now coming back to our reflection utils, we need to develop some methods that let us get access to these singleton instances and set values on them. Okay, so the very first one is public static, and this guy returns .NET object because we don't know what will be the property or the field. Okay, and we say get singleton property. This guy accepts a type, and we call it type, and a string as singleton, if I can type, property name, and some binding flags. Binding flags, I call it flags. And I instantiate it as public or don't forget this is bitwise operation. I will speak about bitwise operations later, but static is the next one. What I'm doing here is that I'm letting the users sending in their own flags, but if they don't, that's okay. I'm assigning for timing, let me return false. or return null actually, so that I get rid of those errors. I'm assigning my own flags by default. Why public and why static? Because if you look, the singletons most of the time should be public. Actually, I think 100% of time your singletons are public, and they are static because they are singleton. But for whatever reason, for whatever stupid reason, someone may want an internal or protected static class, or may not this guy be static. That wouldn't be a singleton, but whatever. So I'm letting this guy sending in his own flags. Why I'm exposing these flags outside of the method is that I'm developing an API, not a game. If I was developing my own game, then I wouldn't expose this guy at all. But when you are developing API, you need to cover everyone's need outside of your own project. So exposing fields like this is one of the ways, one of the easiest ways to handle that need meeting. Okay, so now we say if type equals to null, then of course return null. We don't have anything else to do. So we say var instance property equals to type dot get property singleton property name. So we send in a string as the property we want and the flags that we want. Okay, remember the flags right now is public static. Now we check if instance property equals null. This means that the property name that we sent in wasn't existing on this class type. What we do? Well, we return null. Then we say var instance equals to. Now instance property dot get value. Now this guy on properties, you look, this the second overload that is highlighted asks for an object, an index array of objects. Well, for the object we can send in null, and for the indexing we can send in null. What does this mean? This means that, hey, remember node editor window has a assembly type. Okay, so go into the type, we went into the type, find a property that has a name, we send in the name, that is this flag. This flag says public static. Okay, so we want a public static with a name that is a property. If you found this, then get its value. Now remember, the instance by itself is just a member info, a property info in this case. Okay, now it has a get and set. If it was a field, again it has a get and set, but it wouldn't be exposed by default. So from this instance, get its value. I don't care about the object itself. It's a static, so it will sit on every instance. And this property has no indexing. So I set the first null as the object, the second null as instancing. Now we check if instance equals to null, then please return null. Otherwise, return instance. And actually, this guy can be removed. It's either instance or it's null. Okay? Now, I will copy this guy, paste this guy, and I will say get singleton field. So I will copy this for time being, then I will comment it and set it as a field. So if it was a field like before, the previous method wouldn't work because it asks for a property. This guy is not a property now, it's a field. Okay, so we are looking for a field now. Okay, and of course I need to change this guy. So singleton field name. And again, flags are almost 100% of the time public and static. So we check if the type is null, then that's it. Then this is instant no. Instance field. Okay. So now we instead of getting the property, we are asking for a field with the name and the flag, and then we want to get its value, but this time we don't have indexing. We just have the object. Okay. So right now we are saying go to the type, get the field with this name, okay, that is public and static as flags. If it exists, get its value, and I don't care about what object I'm getting the value because it's a static, okay? It sits on every instance of the object. So then return it. If it found it, it will return the type. If it the value actually. If it didn't find it, then it will return null. Cool. Now we got our instance of our class, but we want to set a field on that instance. Okay? And I will develop again two methods, one for a property and one for an instance. And well, actually, I need to develop it as for. I forgot something. Okay, public, static, and this time I will send out bool that says I was successful or not. The name would become crazy. Set singleton property. Okay, I ask it for a type. I ask for a string singleton name. I ask for a string, and that is the property name. I ask for a bool that says singleton is property, and I assign it to be true by default. Before this, remember your default values should go after every other thing. So I accept an object as a value. Okay, then I will say if the singleton is a property or not, and then I will say binding flags, I call it flags, and again the flags are this guy. And I need to say that is singleton flags so that the user knows what is this guy. So we say object instance. Okay, then we say if singleton is property. Where is that? Singleton is property. Then we say instance equals to get singleton property on this type with singleton name with singleton flags. Okay? Else, not equals, else we say instance equals to get singleton field with the type singleton name and singleton flags. Okay, and it says that, hey, convert it to this operator. Okay, and then this guy says join declaration and that. So we are checking if our singleton is a property or not. If it's a property, then we get the property. It's a field, get the field. After that, we say if our instance equals null, then return false, meaning that we can't set this guy. Okay. After that, we say oh heck. Okay, we say var property to set equals to type dot get property, and that is property name that we want. Okay, then after that we say if property to set equals to null, then return again false. After that we say property to set dot set value, and now you see that it I'm going for this second overload again. It asks for an object, for a value, and indexing. Okay, so the object this time is our instance, so we want to set this value on the instance. The value that we want to set is value, and the indexing is null. Okay, and at the end we return true, meaning that we were successful on setting this value. Now I will copy this guy, paste this guy, set singleton, but this time what we are going to set is a field. Okay, so we change this guy to field name. Okay, now again we are checking if the singleton is property or not. We get the instance of the singleton we want, and then this guy is field to set equals the type, but this time we are getting the field. Okay, and when we are setting, we don't have indexing, and that's it. So remember, the only difference between setting a value on a property and the field is that indexing. For properties we have something called indexing of the property. Fields doesn't have that. Okay, now we developed our very handy tools here now, because right now if I go here, I can, for example, say var window equals to window type, actually equals to reflection utils dot get type. The type we want is node editor window. The namespace that we want, well, we have it here, is this guy. Okay, so now we have our window type, so we can easily say reflection utils dot, and remember we know that it's a field. No, I want it to be property. Okay, so we know that our instance is a property, so we can say reflection utils dot set singleton field, because the field is this guy. Where is this thing? Graph schema. We want to set the graph schema as our comment, current graph schema actually. Where is this guy? Current graph schema. Okay, so we want the field. but the first thing we want is window type. Then we want a singleton name, that is instance. Then we are asking for a field name. The field name is current graph schema. Then we ask if what is the value. The value is current graph schema that we want to send in. Then we ask if the singleton is a property or not. Yes, it is. And you see that already it says that if you look, ReSharper say, hey, it's redundant, because we are assigned, ouch, we are assigned a default value here to be true, okay? And this does everything for us. It goes to this window type, finds the instance, finds the field, and assigns this value to this field. So these two lines are equivalent of this line. Okay? And I need to open my Unity now. Okay? And I had this test. I keep that one, although I'm not using it anymore. Okay. So now I should be able to say, hey, build solution. Come on. Build for successful. I will come back to Unity so that it will rebuild. And remember, now inside our resources database, I have nothing. Okay? Then I will say boss, node graph, and I will create a new graph calling it my graph. And if everything works, I should see this work view to be changed to my graph. So I hit create, and you see it creates. Why everything is working now? Well, first of all, my graph, the graph name is my graph. Okay? The schema has no selected node. But where is that guy? Where's the current graph? Nodes related graph is my graph. Okay. So if you recall, when we were developing our views, work view, we said if the current graph does not equal null, set the title to this guy. Now we can change it, and we say current graph dot name, or was it graph name? What did I name it? Whatever. Okay. So if I come back to Unity, now it shows my graph. I need to build the project. Derp. Build solution. Let it run. My graph schema. Yeah. Okay. So you see that I, using reflection, created a graph and assigned that graph here. Well, there was another way to do this thing without using reflection. I will show you how, and I will tell you why didn't I use it. I could come up here and say public static bool needs, or we say update graph, okay, something like that, and public static graph schema. What the hell? What was that? Why didn't you find it? Graph schema, and I will call it active schema. Okay? And instead of this thing here, I could say, you know, active schema equals to current graph schema, and update graph equals to true. And then inside work view, on update view, I could ask for if our graph utils dot update graph, then we could say current graph equals to graph utils dot active schema, then would say active schema equals to null and update graph equals to false. Okay, this would cause every frame 2 times per frame actually, that our work view would come back and look at this guy and say, hey, should I update my graph? The moment we were setting it to true, it would come and fetch this guy from it. Well, it would eliminate the need of using reflection, but there is a reason I'm not doing it this way. First of all, this approach would cause checking our instance 2 times per frame. Second of all, down the road, I would use this graph system to, actually, let me change it back to, well, I can do something. Work view, where are you? Dot sub, comma, not dot sub string of 0, comma, length is 1, 2, 3, 4, 5, 6, 7. Okay. This guy, that length minus 7, so that I just see that the name without schema. Okay, and build solution. So down the road, I will use this system for developing our behavior trees, and I will have an agent class for my NPC and enemies that would use this system on their behavior trees. And I want to be able to look inside a single agent's behavior tree and see what he's doing at that time, to have a visual debugging system. And that is when I want to get instance of this window and then assign the copy of that agent's behavior tree to this graph so that it would update on the fly. Again, I could use that approach for setting the values on this guy. But, who knows when I need to set properties and fields on singleton instances. So sooner or later, I had to write these few reflection codes. And don't be afraid of using reflection. Reflection is fast. If you know, Unity is using reflection all the time. I mean, is declared. Okay, that's on test. Let me get rid of that guy. I don't like it. Where is that editor? Test. Show in Explorer. Edit in Notepad++. Get rid of everything. Delete and save. That I had done it on my second monitor, so that I get rid of this error here. There we go. So I knew that I had to write this guy sooner or later. So why not utilizing it right now? And Unity is using reflection all the time. If you ever search the web about obfuscating your code, and I will talk about what is obfuscation later on. And what is wrong with you? Nah, shut up. Okay? So, if you obfuscate your code, then you come back to Unity, you would see that Unity is yelling at you, hey, I can't find this, I can't find that, because Unity is using reflection, and it's heavily using reflection. And when you obfuscate your code, sometimes you lose pointers to methods, stuff like that, advanced stuff. But long story short, it will cause Unity to not find the reflected types. And as you see, Unity is using reflection all the time, and your games are running on, I don't know, sometimes 60 frames per second, sometimes 200 frames per second. So the reflection is not slowing you down. Also, remember, I'm using this guy on the editor side, and I told you my policy is that when I can do anything on the editor, I don't care about the speed that much. Maybe 1 frame per second drop for, I don't know, 1 second. That's nothing. Even 3 minutes of waiting, 2 minutes of waiting for some very heavily processing stuff in editor is completely acceptable. And you see that Unity doesn't care either, because if you ever developed your train system, okay, let me show you one of these as an example. Where is my scene view? Thank you. So right now I have nothing, okay? I just create, where is that? 3D train. You suddenly see this guy starting on below your monitor. A slide bar, a process bar that is going forward, and look how long it will take. It's just 5 from 11, 6 from 11, 7 from 11, and I'm still talking and it's still on 7 from 11, because that's real-time global illumination baking on your train. And it just now finished, okay? So if I choose any, and I mean any, okay, I think something like this, any tool, and I start painting, well, this won't hurt anymore, but the story is that even Unity doesn't care sometimes about the processing, because you look at this train, ugly train, because the story is that, you know, you see it started, it just started again and again, and depending on your CPU, sometimes it's very time consuming, a very time consuming process. And Unity is telling you that, hey, you are doing something heavy. You are, I don't know, you're sculpting what is the size of this guy? 1K by default? No, 500 meters by 500 meters train, and I'm just baking the illumination on the fly for you. So don't mind, continue your job. I'm doing it on multi-threaded, but you know, on slower CPUs, this can ridiculously slow your process. So every now and then you see that guys on web comes to, you know, window, lighting, and down here they disable auto when they are sculpting their train. And when they finish Terra making, then they return it back to on, and the process will start. Sometimes based on your CPUs and the objects in the scene, this can take hours. And I mean it, hours means that you will leave it alone for the night. But that's the process that Unity takes, and that's the process I feel very proper for these kind of situations. If whatever you are doing takes time in editor, but it will run on the fly at the runtime without any hiccups, without any problem, let it be. Don't worry about it. And I seriously want to learn how I can put this guy to work myself. I know how to put a status bar inside inspectors or windows, but I want here this exactly same thing. Anyway, another thing that I would like is putting in the buttons in here. Oh well, I'm talking nonsense now. Okay, so let me get rid of this tree. In this video, we finished our creation of the graph, and right now you see that it resetted itself because I don't have any way of loading a graph, but that is for next video. I will load the graph on the fly. So now we have some very useful reflection utilities that we can get our type without knowing the fully qualified name, just by name of the class and maybe the name of the namespace. And then we can set fields and properties on singletons that are field or property. Very flexible situation here. Okay? I hope you enjoyed this episode. Have fun, everyone. Bye-bye.